Is Yadnesh Narkhede. I'm a final year Btech student from Department of Data Science at GHRCEM College of Engineering and Management, Pune. I, along with my team members Vaibhav Kadam and Sadanand Kurhade, developed a project titled that's Confidence Estimation Techniques for White Blood Cells Classification. This project was completed under a guidance of Professor Vaishali Kapure ma'am and Dr. Arti Patle ma'am with our respected HOD Dr. Deepika Azarkar ma'am and project coordinator Professor Rupali Parthe ma'am. So I give you a complete project overview. The acute lymphoblastic leukemia is a serious blood cancer that affects immature white blood cells in our bone marrow. To diagnosis this is a very challenging because the changes in cells are very stable and often difficult to detect manually. So our project focus on an AI based classification white blood cells with a confidence estimation, which means the model not only predict the classes but tells how confident it is in the prediction. This helps reduce misclassification and build trust on clinic issue. Now I have explained the overall project overview. I will walk through the poster. This is a complete summarization of workflow. In this there is a pre-processing, segmentation and feature extraction to model training and confidence estimation. I will explain a part in a simple way so you can clearly understand our system detects acute lymphoblastic leukemia using deep learning. So the first step is the problem statement. The problem statement from this poster you can see the core problem is traditional AI, traditional traditional acute lymphoblastic leukemia depends heavily on human expertise and current AI tools often lack confidence estimation, which may lead to wrong prediction and treatment delay, and sometimes it goes a human error also because it's a manual testing. And so second step is the methodology. So in methodology there are three steps we are following. The first step is data means image pre-processing and segmentation. In that we resize, normalize and enhance the white blood cells image to improve data quality. And the second step is to deep learning classification. We use a CNN based transfer learning learnings models like EfficientNet, MobileNet and ResNet 50 and VGG19 to classify stages of leukemia. And the third step, the main step, is confidence estimation. We apply temperature scaling with the calibrate the model. So the output probability and makes a prediction more reliable for doctors. And the third is the innovation. Our innovation lies in the making the model clinically trustworthy. With the confidence driven AI and advantage image processing and image segmentation like histogram equalization, we ensure better accuracy and interpretability. And the last is scalability. In the system is highly scalable because it can work with the large medical data sets, supports high resolution blurred images, and it can extend to classify other blood cancer in the future. So to move the most important things to implement the implementation section. In this section I will show you how we actually build the model step by step using a collab or Kaggle. I will demonstrate how the image pre-processing, segmentation and training part and final and last confidence estimation. So the first we are importing a simple Python library like pandas for data manipulation, scikit-learn for splitting a data, and CV2 for image preprocessing, and came in for segmentation, and this is a uh, dense net dropouts and global average pooling, batch normalization. It's a deep learning library. So we created empty files in Colab for the storage segmented part and original part. So this is a testing and testing and training part. After that, we are segmented in this part. So this is all about a pre-processing part, and here is the starting of a data segmentation part. We're using a k-mean. First, we convert a RGB to lab color space. Mean convert color image to the grayscale conversion. Means black and white. After that, we use binary thresholding to remove a background from images. Means there is a noise present in images, so we remove it. So this is our six outputs that we got from the image segmentation parts. The image A means it is a original image, and image B means we convert RGB to lab color base, and image C means it is a binary thresholding. We use the binary thresholding. And image D, this is a K-mean clustering, which means we are grouping the blurred cells pixel. And image E is a mass generated, means segmented image. And the image F, we are place the mask on the original images. After that, we are splitting data into data test, train, test, and validation split. This is a graph of the data set. Our data set is imbalanced data set, so we imbalanced data sets. Because of our imbalanced data sets, we are using uh, transfer learning. Transfer learning. In transfer learning, we are using a MobileNet v2 because MobileNet v2 sometimes got a perfect for the medical images, and in this we are using initial learning rate, means 0.001%, and we are epochs like 15. We have processed 15 epochs and 30 and I think 32 batch size. Yes, there is a batch size 32 and size is 224 cross 224 and 3 dimensional. And after all of this, we are getting accuracy that is 99% and validation accuracy is 94%. I think there is a slightly overfit model. If we are goes to the 20 or 25 epochs, then it's the model is perfect. We can say it perfect. So this is the training loss and validation loss, and this is a training accuracy and validation accuracy. After all of this, we use the confusion matrix to plot the true value, means true positive, false positive, like this. This is the confusion matrix. It is a in percentage. This is one type of test case. We are feeding a 25 images to the model, and the model get the accuracy. Means in out of 25, there are only one is a wrong prediction. Means our model is getting better outputs. And the last step, we are applying the confidence estimation. In confidence estimation, we are applying a temperature scaling, means softmax with the temperature scaling. Here the optimal temperature we got 1, and if we use after applying a confidence estimation, we put the 1 images for the testing. and we feed a pre-cancer file, and our output is got also pre, but the confidence is 46%. So what's really happening here? Mm, Before calibration, our model was probably overconfidence. For example, it's a 99% sure, but often sometimes wrong. After applying temperature scaling, the model become trustful. For example, 47% sure because the prediction is actually uncertain. So 45% after calibration, it not worse. It's just the honest. If we push it more, means 80% or 85%, you will go back to the lying confidence. So and there is a one thing, why do many medical images show 40 to 60, between 40 to 60% confidence? Because uh, blood cell stages begin versus pre versus pro are very similar, had even for human experts. Model sees ambiguous features, so the low confidence is totally normal. In medical field, low confidence can be a good things because the system wants that is unsure. So this is all about model implementation, and with the implementation successfully completed, we also took an important academic steps. We prepared a copyright submission for this project and submitted our research paper to the IEEE Pune Conference 2025. I am happy to share that our paper was accepted and have received an official acceptance mail from IEEE. This is a greater achievement for our teams. So this is all about my projects. Thank you for watching this video. If we hope our project inspire more innovation in healthcare using artificial intelligence and deep learning. If you have any questions, feel free to ask. Thank you.